So, there's a mysterious doorway in the middle of Antarctica. Some people think it's Bigfoot's vacation home, or a shuttlecraft from Star Trek, or maybe a door to Agartha, a mythical kingdom some people believe is located in the center of the Earth. Well, the scientists debunked all these poetic theories and explained that what looks like a mysterious doorway is located in an area of fast sea ice. It's offshore of the coast and is full of little islands with shallow water around them. When ice flows around hard rocks hidden underneath, it can create patterns that look odd but are totally normal. In this spot, the ice is thin, so the rocks underneath have a big effect on how the ice moves. The cold winds in Antarctica also shape the ice and snow and make it look like they're lines and shapes. So, the mysterious doorway is just a rocky ridge poking out because the ice has melted a little. The top of the doorway is the tip of the rock, and the sides are snowy trails left by strong winds blowing in the same direction. It's essentially an iceberg that got stranded and is melting in one place. One YouTuber found another out-of-place mysterious object more than 150 miles off the shore of Antarctica, a 400-foot-long ice ship. The internet went wild with theories like that the ship must have ended up there right from the Bermuda Triangle. But there was no scientific proof that it was a ship and not just a large chunk of ice. And once some other internet users revisited the place, they noticed the ice melted in the summer and the hypothetical ship was gone. Another mysterious Google Maps find in Antarctica was a pyramid. And before you make up an exciting theory about how the ancient Egyptians built a secret base here, I have to tell you it turned out to be just a mountain. It's part of the tallest mountain range in Antarctica that stretches for almost 250 miles. It's not the first pyramid on this continent, as explorers from the British Antarctic expedition found another unusually shaped mountain and nicknamed it the Pyramid. But this one didn't even have a pyramid shape. Here's one Antarctic find that definitely won't disappoint you: a giant ice shelf that reminded scientists of the Grand Canyon. A special submarine robot named RAN covered over 600 miles under the thick ice and brought back some amazing footage of icy mountains, valleys, flat plateaus, and swirly patterns made entirely of ice. One of the strangest things RAN found was giant bowl-shaped holes, or scoops, in the ice. Sadly, scientists lost track of the robot. They think that curious Weddell seals may have accidentally bumped into RAN and caused it to get stuck. To save energy, RAN probably shut itself down, and the scientists couldn't find it again. But the team is hoping to build a new robot and continue exploring this icy canyon to see how the patterns under the ice might change over the years. Another huge Antarctic canyon was found thanks to bad weather. A team of sound experts had to pause their work at the Casey Research Station in a storm. Instead of waiting around, they decided to use the unexpected free time to map the seafloor near Adams Glacier. And that's how they found a canyon that is almost 7,000 feet deep, almost 30,000 feet wide, and stretches over 28 miles away from the glacier. During the mapping, they discovered just part of the canyon before they had to go back to the research station. But when bad weather came in again, the ship went back and mapped more of the canyon. They were working in waves up to 13 feet high and super powerful winds, but they managed to get about 15 hours of data to complete their map. On the way back to Australia, they stopped one last time, and now they've got a full picture of the canyon. Studying it is helping scientists learn more about the history of glaciers and the interaction between the Antarctic ice sheet and the ocean. Now, there's a frozen lake in Antarctica called Lake Enigma. For a long time, people thought the lake was completely frozen solid. But during one expedition, researchers found that under the thick ice, there was a layer of liquid water about 40 feet deep. To learn more, they drilled through the ice and sent down a camera to explore what was hiding in the lake's depths. The lake's water, which they think comes from the nearby amorphous glacier through a secret underground pathway, was filled with strange microbial life. These tiny microbes lived in mats that covered the lake bed. Some of the mats were thin and spiky, and others looked like crumpled carpets, or even small tree-like shapes that grew up to 16 inches. Many of the microbes could make their own food through photosynthesis, just like plants do, and it gave the lake a high amount of oxygen. One of the coolest discoveries was a type of microbe which usually lives in low-oxygen places. Lake Enigma might be similar to environments on icy moons like Europa or Enceladus, so it could mean that these moons also have hidden water under their ice and possibly microbial life too. One more mind-boggling discovery from Antarctica is tiny pieces of amber in mudstone, found here for the very first time. It took scientists years of studying incredibly well-preserved fossilized roots, pollen, and spores that they found back in 2017. Amber proves that resin-producing trees once grew in Antarctica, part of a lush rainforest that existed near the South Pole during the mid-Cretaceous period. Back then, disclaimer, I wasn't around then, the trees would have had to survive through months of darkness during the long Antarctic winters. Scientists believe they adapted by going dormant for a long time. The amber pieces the scientists found are tiny, but they are beautiful shades of yellow and orange with bumpy surfaces that show how the resin flowed out of the trees. This resin likely leaked out to protect the trees from insects. It was preserved because water quickly covered it and kept it safe from sunlight and air. A scientist was browsing through satellite images for brown trails of penguin waste and found 4 new colonies of emperor penguins at the base of the globe. These new colonies likely have been around for years, though 3 of them are rather small, with fewer than 1,000 breeding penguins each. One of the new colonies was found close to a place called the Lazarev Ice Shelf, where there used to be a larger penguin colony. They thought this colony went extinct in 2019, but it seems the penguins have just moved a bit because of changing sea ice conditions. So studying them can help us learn more about how emperor penguins adapt to changes in the environment. Now, there used to be a giant river system in Antarctica 40 million years ago. Researchers found proof of it after studying soft sediments and hard rocks from the frozen seabed. They looked at tiny bits of radioactive elements, like uranium and lead, and learned that the deeper dirt came from the time of dinosaurs. The dirt closer to the surface was younger and had an interesting pattern, like the kind you see in river deltas today, such as in the Mississippi River or Rio Grande. Scientists found tiny signs of life in the sand. The river that once flowed here started in the Antarctic Mountains and traveled 930 miles before it reached the sea. Researchers kept studying newer layers of dirt from about 20 million years ago. They hope this will help them predict what the Earth's weather patterns might be like in the future. Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the Maud Rise Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the Maud Rise Polynya isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data – satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers. And they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwana land, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen and sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland, freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, it was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsev Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtzes are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse.
A vast expanse of white snow, freezing winds, lifeless landscapes, and weird, eerie signals seemingly coming from within Earth. These radio pulses occur in Antarctica, and no one can figure out what they are and where they're coming from. You see, scientists are running an experiment called ANITA, short for Antarctica Impulsive Transient Antenna. Basically, it's a bunch of detectors strapped to giant balloons and floating way up above the South Pole. Their job is to detect extremely high-energy neutrinos. How do they spot them? Right at the moment when neutrinos come into contact with ice and produce an intense, short burst of radio waves. Now, neutrinos are these tiny, almost massless particles that don't have an electric charge. They're everywhere, and billions of them are flying through you every second, even while you're watching this video. Neutrinos come from all over the place, from the sun, exploding stars, deep space, even from under your feet. The sun pumps them out non-stop as it fuses hydrogen into helium. Stars that are going off blast out huge bursts of neutrinos during supernova explosions. When high-energy cosmic rays hit our atmosphere, they make new neutrinos that rain down on us too. And some even come from radioactive stuff decaying inside Earth. The oldest neutrinos have been flying through the universe since the Big Bang, but they're practically invisible because they almost never react with anything. That's why scientists use unbelievable experiments like ANITA to try and catch even a few of them. But let's get back to that fateful day when everything changed. Normally, the radio signals produced by neutrinos bounce off the ice and fly upward. That's where ANITA can catch them. This is the whole point of the experiment, to study neutrinos and learn more about distant cosmic events like supernovas or whatever's happening light years away. But then something really weird happened. The detectors picked up radio waves that weren't bouncing off the ice at all. They looked like they were coming from below the horizon, from under the ice. Now, this shouldn't even be possible. According to everything we know about physics, signals can't just travel upward through solid rock and ice. One of the researchers, Stephanie Wiesel from Penn State, also said that those radio waves were coming in at super steep angles, like 30 degrees below the surface. The only way that could happen is if the signal had passed through thousands of miles of solid rock before hitting the detector. But if that were true, the rock would have completely absorbed it. So something just didn't add up. The team ran all the numbers and still got no clear answer. But for them, it was an interesting problem, since they didn't actually know what those anomalies were. What they did know was that they were probably not neutrinos.
That's because if the team does detect a neutrino, that means it's traveled an insane distance without bumping into anything, possibly all the way from the edge of the observable universe. So, whatever ANITA has picked up, it's not behaving like anything scientists have seen before. It might mean there's some totally new type of particle out there, or maybe something else is going on that we just don't understand yet. They publish the findings in physical review letters, but the mystery remains unsolved. No one really knows what's going on under that Antarctic ice, just that something out there isn't playing by the rules. Now, if scientists actually manage to detect and trace where those crazy fast particles come from, they can learn tons of stuff about the universe. Way more than even the biggest, most expensive telescopes allow us to see. You see, neutrinos basically zip through space almost at the speed of light, barely bumping into anything. It means they can carry untouched data about events that happened millions or even billions of light years away. That's why Wiesel and a bunch of other researchers around the world have been building these insanely sensitive detectors to catch neutrino signals. Even the tiniest ones are super important, because in this field, one tiny blip of data can hold a treasure chest of information. So, researchers have been designing setups in both Antarctica and South America to catch these rare particles. ANITA is one of those detectors, and Antarctica's the perfect spot for it. There's hardly any radio noise, there are no cities, no traffic, and no random interference. The setup is actually pretty cool. They attach a cluster of radio antennas to a giant balloon, send it a few dozen miles up into the sky, and make it float over the endless stretches of white ice. From up there, it points downward, listening for faint radio signals coming from deep inside the ice. When one of those super rare neutrinos, specifically a tau neutrino, hits the ice, it creates another particle called a tau lepton. That lepton then shoots out of the ice and starts breaking down, losing energy and turning into smaller bits. That decay process gives off what's called an air shower, kind of like a spray of invisible sparks flying through the air. If we could actually see those air showers with our eyes, they'd look like someone waving a sparkler through the dark, bright streaks trailing behind as it moves. Studying the direction and pattern of these signals, the ones from the ice showers, and the ones in the air showers, scientists can figure out where the original particle came from. Usually it's super precise, kind of like bouncing a ball off the ground. You can predict where it'll go. But these weird new signals don't bounce the way they're supposed to. The angles are all wrong, way steeper than anything the models can explain. So the team dug deeper. First, they looked at all the data from ANITA's multiple balloon flights. Then they compared it against tons of computer simulations of cosmic rays and neutrinos and filtered out all the usual background noise. They even cross-checked their results with other experiments like the ice cube detector, which is also located in Antarctica. and the Pierre Auger Observatory in Argentina. They wanted to see if anyone else had picked up similar upward-going air showers. And guess what? Things got even weirder. They found nothing. No other detectors had picked up anything that could explain what ANITA had seen. That's why the researchers ended up calling the whole situation anomalous. It basically means, yeah, we have no idea what this is, but it sure isn't behaving like a neutrino. Whistle explained that the signals just didn't fit into the usual picture of how particles were supposed to act. Some people have floated ideas, like maybe it's some new kind of physics, or a hint of dark matter. Dark matter is basically that invisible stuff that keeps the universe from falling apart. It's everywhere. We just can't see it. Scientists have been trying to figure out what it actually is for almost a century, and it's still one of the biggest mysteries out there. Everything we can see, like stars, planets, people, dogs, makes up only about 5% of the universe, and dark matter makes up around 27%. The rest is something even stranger called dark energy. Scientists think dark matter is what gives galaxies their shape and holds everything together like cosmic glue. Without it, the universe would look totally different. It would be totally amazing to find out that this theory is true. But since IceCube and Auger haven't caught the same thing, that really limits the possibilities. Penn State has been in the neutrino detecting game for almost a decade now, building detectors and analyzing all kinds of cosmic signals. And the team is already working on their next big project, a brand new detector called Puel. It's going to be bigger, more sensitive, and way better at spotting those elusive neutrino signals. For now, this remains just one of those long-running cosmic mysteries that keep scientists awake at night. But the team is optimistic. When Pueo goes up, it'll have better sensors, which means if there really are more of these anomalies out there, this time they'll catch them. And maybe then we'll finally figure out what's behind them.
Ice piracy is like Pirates of the Caribbean, but you gotta swap those tropical seas for icy, freezing waters. And the captain here isn't Jack Sparrow, but a massive glacier in Antarctica. Meet the Kolar East Glacier. Its calm, sparkling surface might look innocent, but don't be mistaken, it is a pirate, and a pretty skilled one too. Instead of gold, it's been stealing ice from its neighbors at record speed, and scientists can't believe what they're seeing. So, what exactly is ice piracy? Arr! This is a strange kind of glacier movement where one glacier starts taking ice from another nearby. Instead of minding its own business and slowly sliding toward the sea, it suddenly changes course and begins pulling ice that used to belong to its neighbor. The pirate glacier speeds up, the victim slows down. The problem is that the balance of ice in the region might get completely thrown off. This isn't brand new information, though. Scientists have known about this quirky behavior for quite a while. But they used to think that this process took hundreds, maybe even thousands of years. Now, something really strange is happening in Antarctica. We're seeing, for the first time ever, a glacier pirate in action, and it's moving much, much faster than anyone expected. It all started when researchers from the University of Leeds began looking at satellite images taken between 2005 and 2022. They wanted to analyze the rates of flow from 8 ice streams in West Antarctica. And yes, glaciers do move. Think of them as huge piles of snow that have turned into solid ice over time. This ice slowly changes shape, shifts, and moves. That's why glaciers are often called rivers of ice, because they flow, for real. Gravity is what makes it happen. The ice slowly slides and deforms under its own weight, thanks to the pull of gravity. And when it comes to glacial movements, they can either advance or retreat. If more snow and ice build up and melt away, break off, or evaporate, a glacier will advance. But if it loses more than it gains, it will retreat. Oh, and glaciers also move at different speeds, depending on things like the slope of the land beneath them. But if that flow starts speeding up, well, that's bad news for coastal communities all over the world, because that means more ice is moving from land into the ocean, which contributes to Antarctic ice loss and, eventually, sea level rise. Now, back to the recent ice research in Antarctica. The team calculated ice velocity using a tracking technique that measures how visible features, like cracks or rifts on the ice surface, shift over time. And they found that 7 of those 8 Antarctic glaciers had sped up. On average, they've doubled their speed since 2005. Given the impacts of how Antarctica's climate is changing, warming up more and more each year, this doesn't really come as a surprise. But here's something strange. One glacier, just one, slowed down. We're talking about the Polar West Glacier. It slowed by about 10% over the study period. But how can a massive chunk of ice just hit the brakes, so to speak? To figure that out, researchers looked at its surroundings, and there it was, the culprit, the Polar East Glacier. Experts think Polar West slowed down because it's flowing toward its pirate neighbor, Captain Polar East. That one's moving much faster. In fact, it's one of the fastest glaciers in the area. Its speed has been increasing by about 105 feet every year over the study period. Okay, that might sound slow, even for a tortoise. But for a glacier, that's disturbingly fast. Polar East is the Usain Bolt of ice chunks, and that's not even the most impressive part. The strange thing is that it changed its flow direction. Instead of moving straight ahead like it used to, it's now turning towards its neighbor, Polar West, and pulling ice from it. Scientists think this is happening because the ice at the point where the glacier meets the ocean is melting faster than before. That glacier melting makes the ice thinner, and as it thins, it changes the way the ice upstream flows. So now, instead of feeding both glaciers evenly, more of that ice is being funneled onto Polar East. In short, Polar East is speeding up and changing its course. So now it's pulling or stealing ice from its slower neighbor. And just like that, this mysterious glacier in Antarctica became a real ice pirate. Okay, this whole ice piracy thing isn't that weird. I mean, it's part of how glaciers normally behave. Slow, dramatic, and occasionally a little mischievous. What really blows scientists' minds is how fast it's happening. They used to think this was a super slow process, something that would take hundreds or even thousands of years. But this one is taking place in just 18 years. And this is a huge satellite discovery in Antarctica. Scientists were only able to spot it thanks to the Copernicus Sentinel-1 mission, a pair of European satellites that use radar to keep an eye on Earth's surface. They can track changes in ice, land, and ocean with incredible precision and coverage, making them perfect for studying how the polar regions are changing. Because here's the thing, keeping an eye on the coldest parts of our planet is becoming essential for our future. And this particular part of Antarctica, where both the Polar West and East glaciers are located, is thinning faster than anywhere else. Its glaciers are retreating at record speed. The grounding line, the point where the glacier stops resting on land and starts floating on the sea, is moving backward. When that happens, the ice sheet slides into the ocean even faster. But scientists say glaciers aren't just melting, they're reshaping themselves in completely new ways. And that's exactly what's happening with the Polar East Glacier. Seeing a pirate glacier in action firsthand has once again changed how scientists look at things. The new data on ice piracy shows something they've never seen before. Glaciers and floating ice shelves are interacting in new and surprising ways. So, more and more, experts need to rethink how these icy giants behave as the world warms up. And that's a big deal, because they play a significant role in how fast sea levels rise this century. In fact, Antarctica's glaciers are one of the biggest reasons our oceans are swelling. The continent is losing about 135 billion tons of ice every year. That's like dumping tens of millions of Olympic-sized pools of water into the ocean annually. If all of its ice melted, sea levels would rise by about 190 feet. That kind of rise would flood much of Florida and huge areas of the Netherlands and Bangladesh, for example. Many small island nations would completely vanish beneath the waves. Now, you might be asking yourself, what's hiding beneath all of Antarctica's ice? Well, it might look flat from above, but underneath that mile-thick layer of ice lies a whole landscape of steep mountains and deep valleys, crossed by winding rivers. Those hidden rivers could play a crucial role in how the ice sheet reacts to all this unusual warmth. Scientists now predict that as Antarctica's ice sheet keeps melting and thinning over the next few decades, those subglacial rivers will grow, overflow, and shift into new paths. This could make some of the biggest glaciers near the coast start to break apart faster, and that would make sea levels rise more quickly. So that's why understanding these changing dynamics and glacier movement, like our icy pirate, is so important. Every new discovery helps scientists figure out what's really driving Antarctica's glaciers and how they are responding to a warming world. The more we learn about these frozen giants, the better we can predict what might happen next and how changes down in Antarctica could ripple across the entire planet.
Welcome to one of the most mysterious and unexplored places on Earth. But what's so special about that? It's just some icy peaks and the endless snowy expanse of Antarctica. Yeah, that's right, but there's still a planetary scale mystery here. No matter how hard you try, you won't see a hidden mountain range, giant, unexplored land where no human has ever set foot, and it lies under another layer of mountains. It's like a nesting doll, but the size of a continent. These mountains hide Antarctica secrets, and these secrets can tell us something awesome about the ancient history of our planet. This gigantic unexplored territory in Antarctica is called the Gamburtsev Subglacial Mountains. And the layer of ice above keeps this place untouched by nature and people. It's like a land inside another land, and it hides more than just mountains. There are valleys, hills, and plains. The whole area is similar to the European Alps, but unfortunately, we can't enjoy the view. Those mountains were first discovered in 1958 using seismological instruments. More than half a century has passed since then, and this place still remains one of the most poorly studied tectonic objects on Earth. Why? Because it's ice. A lot of ice. Who knows? Maybe there are some unknown ancient artifacts lying there. What if they're hiding a secret city or spaceships? It's unlikely, of course, but it would still be interesting to look there. Think about it. Hundreds or even thousands of miles of land that have remained unchanged for hundreds of millions of years. Even if no new species of animals or remains of an ancient civilization are there, this place still has a history. The history of the formation of continents on our planet. And scientists have already figured out some of this story. The mountains buried in Antarctica were originally like ordinary mountains, but as a result of a planetary scale event, they just… Wait a minute. Have you ever wondered how mountain ranges are formed? We see them in real life, in movies, in photos on the internet. We climb them. But how did they appear? Mountains have not always existed on the planet in this form. They appeared as a result of a large-scale collision of tectonic plates. Two giant solid chunks of ground are moving toward each other, then crash, and boom! Millions of tons of the Earth's crust pile on top of each other, mix, and form ledges and gorges. And all this can last for millions of years. Yes, it's a disaster, but it's very slow. Some tectonic plates are still colliding. For example, the Himalayas continue to grow because the Indian and Eurasian plates are still ramming into each other. And this process began about 50 million years ago. The Gamburtsev Mountains under ice experienced a similar event, only much earlier. An article in the journal Earth and Planetary Science Letters says that they appeared during the formation of the supercontinent Gondwana. Two giant pieces of land were separated by a boundless ocean. But then, about 700 million years ago, they collided and formed Gondwana. This supercontinent included the territories of modern Africa, South America, Australia, India, and Antarctica. The giant pieces crashed into each other and released a stream of hot, partially molten rock. This mess grew bigger and bigger, forming mountains. The temperature of those mountains grew, their mass increased, and at some point, Gondwana became unstable. The supercontinent began to collapse under its own weight. The hot rocks below the surface began to flow sideways as a result of a process called gravitational spreading. Take toothpaste and start squeezing it out of the tube. Approximately the same thing happened with billions of tons of red-hot rock. Ancient mountains in Antarctica appeared right during this catastrophic event. You've just watched a visual simulation of global events that took place hundreds of millions of years ago. It looks cool, but how did scientists figure it out? How did they see this planetary-scale destruction? If the Gamburtsev Mountains under ice is one of the most unexplored places in the world, then how could people find out its origin? The answer is simple. Tiny particles of rock have told us about the changing landscape of the planet. These are zircons, but scientists also call them time capsules. This mineral is very handy and resistant to mechanical and chemical influences. It's difficult to crush, it doesn't get affected by erosion, and it doesn't dissolve in water. And there's uranium inside it. This chemical element shows scientists the age of the rock. The fact is that uranium always decays into lead at the same rate. Scientists look at the ratio of uranium and lead and determine the age of minerals with great accuracy. Okay, this sounds a bit complicated. Here's a simple example. Imagine that each mountain belt is a clock that starts ticking at the moment of its formation. That is, after the collision of tectonic plates. After the rock forms, uranium begins its slow decay. The more time passes, the more uranium turns into lead. The rate of this decay is always the same. This decay can last for billions of years. The less uranium is in zircons and the more lead, the older the rock is. And this is how it happens in practice. Geologists take several rock samples. In a lab, they crush it to extract crystalline zircons. Geologists then dissolve the particles in acid to separate uranium from lead. Then they use a special device, a mass spectrometer that accelerates atoms and sorts them by mass. This is a rather complicated process, but the bottom line is that this device shows scientists the amount of uranium and lead. They look at the ratios of these two elements and calculate the age of the rock. Geologists took zircons from sandstones near the Gamburtsev Mountains, studied those particles, looked at the level of uranium, and calculated the chronology of mountain formation. Then they compared the data obtained with the history of our planet and realized that the mountains buried in Antarctica appeared during the formation of the supercontinent Gondwana. But how did they find out that the supercontinent included Australia, India, and Africa? Zirconia from those Antarctic rocks turned out to be very similar to zirconium from those countries. That is, a long time ago, these three continents were together. So, the Gamburtsev Mountains began to grow about 650 million years ago. About 580 million years ago, they reached the height of the Himalayas, and 80 million years later, they experienced the melting of the Earth's crust. And while most of the mountain ranges on the planet were changing and collapsing, the Gamburtsev Mountains under ice remained untouched. Water, soil, wind, earthquakes, gravity, and other natural forces destroy mountain belts. This process is called erosion. But mountains buried in Antarctica haven't experienced anything like this. The cold temperature and the ice sheet around them kept this range unchanged. It's one of the best preserved ancient mountain belts on the planet. Okay, but why do we need to explore these mountains? What difference does it make that the supercontinent Gondwana collapsed in the past? It's possible that plants, frozen bodies of insects, or ancient bacteria have remained preserved under thick layers of ice. What about ancient animals? Many species could have lived on Gondwana. Studying ancient mountains in Antarctica can show us what the planet looked like about 500 million years ago. When Antarctica was a green continent, what lived on it? What happened to this life? Is it possible to revive those ancient creatures after so many years? If scientists were able to calculate the date of the supercontinent's appearance using tiny particles, then imagine what they could find after examining this hidden mountain range. It all sounds very interesting. But there's one problem. To take a small piece of this unknown world, you need to drill through a lot of ice. You need to deliver heavy equipment to one of the most inaccessible continents in the world. build stations, obtain an energy source, and conduct large-scale research. It sounds incredibly expensive, so this hidden territory will probably remain a mystery for a long time. Let's just hope that some billionaire will want to find out Antarctica's secrets and arrange a large-scale expedition there.